Alright, so hello and welcome. We're back again. I said I was going to take a break, but I don't know, I guess my mind has been kind of all over the place lately. Excuse me, took a much longer break than like an hour. It's probably better to take like an hour break and keep going. But, I don't know. A little distracted. I'm a little distracted. I know it's Saturday, it's kind of somewhat on my mind as an excuse. I can kind of do whatever I want on Saturday, but actually, realistically, now that I'm unemployed, it's like every hour counts. Actually, it was always like that, but I don't know, it was somewhat easy to be a little more complacent when I had a job, because you could always justify it as like, well, you're making money, you know. But actually, kind of just moving slowly here. All right, so hello and welcome. Let's see. Let's get it going. Let's return to what we were looking at. So we were looking at the Java visitor pattern, and we want. So okay, it's a tree related question. We're gonna parse a tree and we're gonna build the tree from the parsed output. And actually, they want us to write the parsing code, or from the input rather, build the tree. And the tree's gonna have two data elements. It's gonna be a color and a value, integer value. And there's going to be an adjacency matrix of the different connections between the nodes. And yeah, we can run a depth first search to build our tree using the adjacency matrix, and starting with the one node that doesn't have any children, or excuse me, the one node that doesn't have any parents. Yeah, so let's do that. Let's write some code to do that. Then there's some instructions on functions they want us to write, and we'll get into that afterwards. Let's do the first thing. Yeah, I don't know. For some reason, I kind of like. I looked at this question and I was like, I don't want to do this. I don't know why. That was just my first thought. It's like, not that excited about this question. It just seems, I don't even know. Couldn't even tell you. Couldn't even tell you why I feel that way. Alrighty. So we're going to say integer n is going to be sc.nextInt. Say for int I equals 0, I is less than n, plus I. And just have data of integer array of values, integer array of size n. I'm going to have integer array, or could be booleans really. Do integers, it's fine. Colors, new integer array n. And we're going to say vals of I is going to be equal to sc.nextInt. Same routine. Exactly the same thing. Actually, yeah, same thing. I is less than n, plus I. Colors of I equals sc.nextInt. And then now build the adjacency matrix. What were they saying this is? 1, 2. How many? N-1 subsequent lines contains 2 space separated integers. Oh, that's interesting. Yeah, I guess that makes sense. That actually does make sense. The number of every node has one parent except the root node. So that's why you have n-1 of these lines. That makes sense. And we're going to have for our adjacency matrix neighbors. It's actually going to be, could say an array list, I guess. a list of integer array of an integer arrays. Is that what we want? Neighbors. And I guess that makes sense. How do I want to do this? I don't actually know. An array list of integer arrays? I don't know if that makes sense. Well, I guess it works. I suppose it works. I think it's alright, but there are some questions here. First things first, how are we going to do this? We're going to say, actually the capacity is going to be n-1. Well, I mean, I guess we can initialize this first, you know. And it's going to be neighbors. I don't know if this actually works. Doing this way, we do a new integer array of size n-1, right? And we're going to say, no, not n-1, excuse me. Actually, this should be n. Take that back. Yeah, how big is n in our use cases here? Oh, 10 to the 5th. It's actually kind of a problem, huh? We don't want these to be, we probably want these to be lists too then. Really, it's going to be the children, I think. I think it's the only way to do this reasonably. Yeah, child sets. Parse and store child sets. The reason why you want to get the child set first before you build the tree is because you need a depth, and they didn't say what the order is of these connections, and it really shouldn't matter. But yeah, yeah, they didn't say that the tree is rooted at node 1. Oh, okay, that's nice. That's good. But yeah, because they didn't say what the depth is, and like you can't actually do this like on a whim. You kind of need this children set to be built. I don't know. I don't know if I need to do this. Create the initial values. I think you do, but I don't know. But yeah, anyway, so we don't want to build the full adjacency matrix because that would be too expensive. This will keep things reasonable. So now what I want to do is we're going to parse the two integers. Excuse me, I'm also kind of losing my train of thought in different points. I'm trying to remember what I'm doing. And we want to say is children of a particular index. So how do I do this? We want to say these are the children, right? So A to B means that B is a child of A. So A add B. That's I think how that should go. Right. Parse and store child sets. So let's just see if Do we need that? We don't really need that. Well, yeah. Test. We shouldn't. Nah, it's fine. We reach this line or not. Just want to see what happens here. Compiles. Incompatible types. Really? Required list, integer, found array list, array list. What's the problem? No suitable method found. Why can we not? These are both lists, though. Does it need to be an array list? Is that why? I mean, that's fine. Why is this a problem? Oh, because it's not an array. Oh, that makes sense. Gotcha. Thank you. Clarifying that. Understood. Still kind of getting used to Java. Okay. Index out of bounds. Interesting. Yeah, it's kind of what I thought would happen. Still getting used to Java. I'm used to C++. So some of these things are a little bit awkward for me. No. I think we need to do it this way. We would say children. Yeah, actually we should do it this way. I don't know if there's a better way to do this, quite frankly. But that's pretty much what we want to do. Something like this. We can do this too. Can we I want to see if there's a slightly better way of doing this. Like we can create our array list, but then we can also, I think we're on 7. We can create our array list, but then we're going to set, like we want to specify the initial capacity and then add to the end of the list. Specify position. I guess that's fine. Excuse me. Added a particular index. Let's give it an initial capacity of n, and let's, this actually should be n, not n minus 1. And we're going to add this to I. How about that? Okay, so that works. And then the rest here, we scan all these values and add to our array list of integers. I don't know. I guess you do need to use an array list inside here. You can't abstract that away too. For some reason that doesn't work. I don't know. All right. So right now we parsed all of this, and now we want to create the tree, which we're going to do by Oh, these don't. Wait, what? Oh no. What? Tree node. Yeah, that's what we want. Excuse me. Yeah, tree node. We want the tree node to add children. We want to add children to the tree node. Okay. Yeah, so we're going to create tree nodes and return the root tree node. Okay. Root equals new tree node, and that's going to have a depth of 0. It's going to be, so I said 1 is always going to be, the nodes are 1 indexed. That's kind of interesting too. Excuse me. Yeah. We can subtract 1 for the indices. I think that's fine. And then tree node is going to be, the root is always the 0 index. So the value is vals of 0. The color is colors of 0. Are these integers? So these are enums, right? Yeah, so we should actually convert the integers to colors. We shouldn't use integers, we should use colors. Just write some conversion routine here. If it's 0, then we're going to say colors dot add, or of I rather, is going to be equal to, how do we do this? Just color red. It's color dot red, and then otherwise something like this. And then the depth is going to be, now the depth is what? The root is depth 0, okay. The depth of its parent plus 1, okay. Sure. So that's the root, and what we're going to say is build the tree recursively using a helper function. And we're going to have a, hopefully we have an extra routine we can throw in here. And we're going to take a tree node root, and we're going to take a neighbor set, which is going to be the list of array list integers, and this is going to be the neighbors or children. Yeah, this actually really should be on another line, but that's okay. That should be fine, I think. Yeah. So this routine is what we're going to say, build tree helper. Oh, be right back. Yeah, I have a shower curtain that uses friction to, has a little bar that uses friction to stay up there, and so it falls off every now and then. It's not a very strong system, I guess. Yeah, okay. So build a tree helper. So what we're going to do is we have the base case, which is if. Okay, so we have the root. We're going to I actually don't know. I actually don't know how this works. Which node, maybe? So we say if there is no base case. Yeah, there's actually no base case. There's just root node, root, which is tree node of vals of which node, and colors of which node, and the depth. That's what we want. That's really the thing that's the most challenging. Yeah, and then we just say root, so we're going to say for integer child and children of .get of which node. We're going to say root dot add child of build tree helper recursively of the child with the depth +1 and the children. Yeah, really straightforward. Return the root. Yeah, that's kind of it. Some nodes don't have any children, so those nodes would just be, there's nothing would happen there. They would just create a node and return it. I think it's that simple. Yeah, and actually here, you don't even need this. You just build a tree helper with 0, 0. Which node is 0, depth is 0, and children. All right, what does this look like? Add child, tree child. I really don't like this mode that I'm in here with this, how this is set up. I think this is better. I hope this is better, I don't know. Where is my code? What's the error? Oh, that's an error. Cannot find symbol. Oh, I see. Gotcha. Well, I can make these private static. Keep things simple. Nah, let's not do that. Let's just give them. So vals and colors. Children, so we have vowels, colors, children. We'll do it that way. Integer array, vowels, color array, colors. Yeah, like I said, I could have made these static variables, private static variables, but we don't need to do that. Tree node. Oh. Cannot find symbol. Tree node root equals tree node. Probably because you need to create a new tree node. Again, not super comfortable with Java yet. I guess I shouldn't say that. I guess I'm kind of, yeah, I guess I'm kind of 010. Interesting. Not that I'm not comfortable. I'm still. What am I saying? Not that I'm not comfortable with Java. I'm still getting more comfortable, more familiar. Let's just say more familiar, more comfortable. I don't know. I don't want to say that. I don't want to say those things. I want to say it's not really comfort. It's just in C++, you don't necessarily need to put everything on the heap. You can put things, make things local. Something like this, I guess you might want to put it on the heap. But I don't typically use new very much in my C++ code. You don't actually need to. You can keep things kind of local. Keep things on the stack. But what I tend to do, I mean, a lot of things do end up on the stack though, like the collections, I guess, for C++, probably all of those things end up on the stack. So anyway, I just don't use new so much in C++. I tend not to, so I tend to forget that. That's okay, I shouldn't, that's okay. Sorry, I may not make excuses, just say it. Keep forgetting to do that. Alright, so, okay, so now we have the different visitors we can modify now. So what did they say they wanted for these visitors? They wanted, how much time we have here? 30 minutes, yeah. It's kind of an involved question. Okay, turns the values stored in the node. Okay, that's fine. We got all that sorted out. Implement the 3 different visitors. Get result, return an integer denoting the result, which is different for each class. Okay, visit node, visit leaf. We'll go over those in a moment. Okay, so they explain each one of these visitors and the get result numbers, what they should be. So that's fine. So they'll have 3 different functions. I wonder if there's a way to make these more efficient. I don't think so. There are a couple things like we don't necessarily need to even implement these things, right? Like really just the logic needs to be in the get result part. Alright, the sum of the values in the tree's leaves only. Sum and leaves visitor. Okay, so we don't even need this visit node, so we can do visit leaf. And how's that going to work? There's a tree leaf. Is there a difference between the tree nodes and the tree leaves? I mean, that seems kind of meaningless or redundant. I don't know. This is kind of like how I don't know, man. I don't know. Okay, that's fine. We're not going to use leaves at all. This is kind of, we don't need that. So, alright, well, I don't know, dude. This seems very like a strange kind of a way of doing this. So to get results, we call root.accept. What does this do? Root.accept. Just visit leaf does the same thing for tree nodes. Just calls that visit. This is so confusing. Visitor visit this node, reach child, accept the visitor. Okay, this basically just iterates through the tree. The tree leaf. What does the visit leaf do? Doesn't really do anything, does it? This is so confusing. It's kind of what I was saying before about, like, I don't know, separating the iteration code from the processing of the program. Well, actually, we can make these leaves if we want. It actually isn't that hard to do. Is empty, right? That's so if there are no children, then we're going to return a new tree leaf, which is like this. Right? Let's try that. Okay. See now why they both extend the tree. Okay. Alrighty. Now the question is, sum in leaves visitor. Tree leaves only. So I mean, sure, I guess. I don't know. Like, well, I guess you could do this. You could just say int current result 0 and ret equals current result. Right, and then this is not concurrent at all, but this would just, you'd have leaf, you'd have current result plus equals leaf, And then, but then you can call this a few times, the accept. Yeah. You'd want this to be idempotent, ideally. This wouldn't really do anything. Actually, you would do this. You would do result ready. You can make this, yeah, you can make this idempotent. So result ready is false. And we'll say if not result ready. When you set the ret is going to be the current result. Current result, so result ready equals false. This doesn't work though, because you don't know when you're done calling the. You actually don't have the opportunity to set this result ready to true. The idea is that you want to, when you call the get result, you don't want to be able to call the visit leaf node. You want these to kind of block each other, but the problem here is there's no way to control that. What I'm trying to do is I'm trying to make these visit leaf routines separate from, like, in other words, you could just put, yeah, like the iteration logic can be totally separate, and all you do is just add the sum for when you're visiting a leaf node. I think I get it now. I think I get what they were explaining, what they were saying about how this works. I'm glad we went through the example, but I also feel like this is kind of awkward. This is really awkward. Excuse me, because I don't know, there's like a lot of like control and flexibility that's like kind of missing here now because of yeah, we're separating out, we're exposing only the visitor kind of interface instead of the iteration logic. I get it now though, but it's not great because, like I said, because you know, something like this, like just having a different visit leaf function and visit node function. Part of the problem, especially with something like trees, is that while it's true, you can just set a variable. In other words, you can assume the visiting routine could set something here in this visitor. It's sort of like a local variable almost. It's sort of bound to this visitor, but the problem with that though is it's no longer idempotent. So if we visit again and we set if we set this variable, just give me one moment here. If we set this variable, excuse me, if we update this variable and we run, every time we run this routine, every time we run the visiting routine, the problem is that if we just add to that variable, then if we run that routine again, it'll add again, and we don't really have a way of, I guess, saying like, okay, you know, how do we prevent that? How can we make that that visiting routine, the word would be idempotent, meaning like once we've got a result from the sum, we'd want to start again at 0, right? The next time we calculate the next sum, or just not calculate anything, right? Yeah, and then also there's questions about like, what if you modify the tree, and what does this visit do now? I guess every time you really want to reset, you'd want to have like you'd want to set the state back to 0. Eat between each call, and it's not enough to just set the state after getting the result, because it's not enough to just get the result, because what am I saying? Why is that the case? It's not enough to just get the result, because because you can call the visit leaf multiple times. You can call the accept visiting, the visit. You can visit this multiple times, and then the result would be actually changed each time. So it would compound the previous result. So it's not really how it's supposed to work, I think. Yeah, it's a little bit awkward. You ideally would want to start by setting the current result before you start visiting. Set the result to 0. And then after you visit, see, that's the thing, this visit leaf is called by the iteration logic. That's kind of annoying. I get it though. Like, I get the idea. I think I understand what they're describing now, but I dislike this. I dislike this. How this is done. But this isn't really. This is kind of not how I would want to design something. In my opinion. Seems kind of bad. This seems kind of bad. This will work for these test cases, but I don't really like this. Don't like this very much. Start off at 1. Just the same code, really. We're looking at product of red nodes visitor, return the product of values stored in all red nodes, including leaves, computed modulo 10 to the 9th plus 7. Okay. So the same code twice, really. So if node.get color is equal to, I don't think you need to use dot equals for, let's just color dot red. Then we're going to say it's going to be equal to current result times. So this is interesting. We're going to take 10 to the 9th plus 7 modulo 10 to the 9th plus 7. So the thing that's tricky about this is actually 10 to the 9th is kind of a big number. Like the multiplication that we do here, I don't think it'll fit in an int necessarily. They give you, hold on. Oh, we can go back. Constraints here. Yeah, so it's between 1 and 1,000. The problem with this is you actually won't fit this number to perform the modular division. So 10 raised to the 9th plus 7. Take this log, right? 10 to the 9th. Makes sense. Let's say you take 10 to the 9th plus 6 and multiply that by 1,000, right? That's what they were suggesting. Yeah. That is 10 to the 12th. Problem with that though is if you take an integer, 3 to the 30, 2 raised to the 31st, that won't fit, right? That you can fit the modulo value in there, but you won't be able to fit the full multiplication won't work because you would need to multiply and then take the modulo, perform the modulo operator. So we kind of have something like this. So have a long, and I don't know, Java long, what we have. Oh, yeah, okay, that's fine. That's perfect. That's exactly perfect. So we'll just say result. It's going to be current result times, oh, yeah, actually we'll do it this way. Current result times node.getValue. Oh yeah, that's what I wanted to check. We compile, and then we're going to set current result equal to modulo 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 7. And we also, right, want to check node value and get color. Node value and get color. Just get value and get color, yeah. So pretty much the same code. Yeah, can we just call visit node of, I don't think we can actually, I think you need to use duplicated code. Yeah, because these are not, doesn't quite work that way. Even though they have the same routines, the leaf class and the node class are different from each other. They have, they both could, yeah, they have the same, they extend the same function, but they're not the same. Yeah, they extend the same, it's not function, they extend the same class. They're both children, they're the same parent, but they are different from each other. And so you couldn't just call the visit node from visit leaf, you actually have to duplicate that code. Interesting. So now, yeah, we did the same thing over here. And the fancy visitor, we said we want, what does that one do? Okay, I think I understand now. This is quite the problem though. This is quite the adventure. Fancy visitor. All right, please don't stop doing that. Fancy visitor implementation must return the absolute difference between the sum of values stored in the tree's non-leaf nodes at even depth, and the sum of values stored in the tree's green leaf nodes. Recall that 0 is an even number. Okay, so absolute difference between the sum of values stored in the tree's non-leaf nodes at even depth. So the sum of the values of the non-leaf nodes at even depth. So that's these ones. And the sum of values, so we get two sums, and the result we reset those sums and compute the difference. Sum of values stored in the tree's green leaf nodes. Okay. That 0 is an even number. Okay, got it. So fancy visitor, we're gonna have also 1,000 times 10 to the 5th. Yeah, that should be fine. So int is going to be current even depth internal node sum, and then there's current green leaf sum. Okay. All right. Ret is going to be the absolute difference. So there's math.absolute of the difference between these two. We're going to put these on a new line. Of this minus the other. Well, we can do we could just rename this to A and B, right? Could just rename it to A and B. And then set these both back to 0. Oops. It's not, like I said, it's not really correct, but it's I guess it's better than nothing, you know? And then turn red. Okay. All right, so now, excuse me, the even depth internal node sum, here it is. We say if node dot get depth modulo 2 is equal to 0, and that's actually it, all you need. Current even depth internal node sum plus equals node dot get value, and then the other one is if node leaf dot get color is equal to color dot green. Then we're going to take our current green leaf sum and increment that by leaf.getValue. All right, that should be sufficient. At least it'll solve. It'll work on the. Oh, did we not get rid of this? This should work for at least these test cases. Possible loss of precision. And long. Well, I guess you could do it this way. Don't really need that. You can make that a long, and then you can also convert this to an int, something like that. It'll always be able to store in an int. You'll always be able to store that in an int. What is the issue? Oh, it's gotta be this same code on the leaf and the node. It's complaining about the same thing twice because you have duplicated code. It's one of the problems with duplicated code. So you make a change here and it doesn't carry over to the other spot. Oh, okay. Alright, let's go for it. See how we do. Oh! Ooh. Well, that's rough. Ooh, wow. All the test cases except for the first one. Really? Ooh, ouch. Ouch. I wonder why. I'm trying to save all my they call them hackos. Trying to save my hackos, man. What is this? Oh, no. Oh. Yeah, what is this? Badges and medals. Huh. 2200, the 6 stars. Interesting. Well, anyway. I'm actually looking for, yeah, there's something about hackos. Oof, got 0 points. Oof. I don't want to unlock the test case, but I'm tempted to do that. I'm actually really surprised. How is it possible that this is wrong? Because, like I was saying, I don't think the code that's being used is the same, right? The test code, the output. You know, we don't need. It's not an issue of being able to. What's the word? Being able to reset the results each time. That doesn't actually matter. Yeah, really, the issue is the code itself should be correct, but should only needs to work one. You know, call the visitor once, call the accept routine, result routine once, and that's it. That's the only real use case we're doing here. If we visit more than once, then these visitors kind of break. When you try to get the result, they're not idempotent, which is like I think part of the problem with the design pattern. But what's interesting to me is that that this was wrong in some test cases, and I wonder why. Did it just break? I want to say it probably must have built the tree incorrectly. Something like that. Excuse me. I don't know. That's a hard one. I think it's this. I think this is the issue. No? That should be fine. What? All right. What's the problem? It's got to be some index issue. Okay. I don't know. I don't know what could it be. What's wrong? I don't know what's wrong. Could be a lot of things. Oh, it overflowed, huh? Really? I wasn't expecting that. I thought we handled that. We should go back. Okay, that's why. Alright, that's like a, yeah. I actually wasn't expecting it to overflow, so it would have taken me a really long time to find out. That's fine. There's no way I could have figured that out, but it's kind of unlikely that I would have. Oh, that's right, because you have 10 to the 9th plus 6 squared, and that's 10 to the 18th, and long for Java was only 2 raised to the 63rd, which is, yeah, it should fit. That should fit. I don't know why. Maybe that's the issue. I need to convert these both to longs. That might be why. Oh, that's definitely why. That's the issue. That is the problem. Again, duplicated code. That's a very subtle thing too. I tend to forget that. Yeah, that's why. That's my fault. I actually should know that. I actually do know better, but didn't handle that correctly. Oh, really? What? What do you mean? Really? What do we get? Okay. Big sigh here. Hold on a second. What is going on? Come on, man. For one, that was wrong. That's incorrect of me. Incorrect. That was, oh, no. Really, the wrong answers. Oh. What? Okay, they're all wrong. All right. Sure. Why is it all so wrong? That's annoying. Okay. Well, what did we say? Huh. Okay. All of them wrong. Nice. Okay, that's always good. Must return the sum of the values in the tree's leaves only. Okay. How? How is this wrong? What? Oh no. If the children of this node is empty, return a tree leaf. That node with the depth. Values. Next integer. Also the nodes. Index. It's 1 indexed, 0 indexed. Yeah, it's 1 indexed. I don't know, man. What happened? What happened? Child could be tree, right? Children don't add child. This is interesting. Oh. not my favorite problem. Not my favorite exercise. What is happening? Why is it wrong? Why? What do you mean? What do you mean? Excuse me, we are... It looks like we're at half, almost. So my output is significantly less than theirs. Why might that be? So maybe there are multiple nodes. No, that doesn't make a lot of sense though. There must be a bug somewhere. I don't like this pattern, man. I blame the pattern. It's not the pattern. It's just I did something wrong here. Necessarily. Excuse me. Did I mix up the colors and the... No, I don't think so. What did I do? I don't understand. Some in leaves. So the visit node doesn't do anything. I don't know, man. This seems pretty much... It must be that the leaf nodes logic is not set correctly, so this is not setting... It's not declaring the leaf nodes leaves. Some of the leaves are leaves but are not being shown as leaves. Yeah, we can test that, actually. We can find out. So... Let's count the leaves. Let's do that. Excuse me. This is not supposed to be so difficult. $44. Okay. Oh. Well, we don't actually know how many leaves there are supposed to be. Seven, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So 17 of these are not leaves. Oh, there's a 0. Wait a second. No. Oh, you gotta be kidding me. What? These are not zero. These are not one indexed, are they? Oh no. Why is node 1 the root, but you also have a node 0? Oh boy. That's really confusing. That might have something to do with it. Oh wow. No, there's... Wait a minute. What is going on up here? Oh, okay. No, we're fine. This is actually part of this is the same line here. No, we're okay. I had the right idea. What did I say? It's 20, it's like 20, how many is this? 10, 11, 12, 13, 14, 15, 16, 17. Okay, so 17 of these are internal nodes. The rest are leaf nodes. And there's 100, right? So 100 minus 17 gives us a lot more than 44. 83? Yeah, we're missing a lot of nodes here, man. What happened? Why? Why are we missing so many nodes? Huh? This is really confusing. Excuse me. I am very confused. What is going on? Oh, we don't want this on separate lines. We want this on the same line. I actually want something like that. Should be 17 lines, I think. 0's got all of these. 3's got all of these. Each of these are maybe 1 or 0. 4's got a bunch. This is just confusing. So each of these nodes have an index and they also have a value. Okay. Is that the problem? Did we not set the value correctly? Maybe that's why. No, we got the values. We have an array of values. That should be fine. Children on 0, 3 has a bunch of children, so all of these are leaf nodes. And then children, leaf node, children, leaves, children, leaves, children. Oh, what's this? How did we get 76 twice? What is that? Wow, that's not correct. 22 has 85 twice. That's not correct. How did that happen? Oh, I know what happened. That's just confusing. It's not a... It's just a kind of a miss... Yeah. Yeah, 3s, okay. How is this incorrect? That's my question. It's making my head hurt thinking about this. I don't know, man. I couldn't tell you. How are they looping over the get value? Color, depth, get value. Am I not setting the value correctly somehow? That's my thinking. Either I'm not setting the, well, I'm not visiting enough children. That's definitely a problem. Yeah, so we can count leaf count and internal node. Do these numbers even add up to 100? Maybe that's the question. But what am I doing wrong? That's the thing. 7. Okay. Definitely incorrect. It's definitely somehow incorrect. 44 and 7 do not add up to 100. Okay. So that's, what's it, 51 nodes we're counting here? But that doesn't make sense because this is supposed to be 100, right? 100 lines. Can actually do some, use a little bit of bash here. $99. Right, which is what we expect. So there are, every node has a parent. But somehow we're not counting every... Something is wrong. Something is wrong. How is this visit set up? So add a child, children add child. That's the tree node. Tree leaf, accept on the leaf, visit leaf, and the tree node. Visit or accept is going to cause the visit on this node, and for each child and the children, which is the array list. We have this array list of children that we set up. For each of those, we would build a subtree. Create this root, return that root. This should be correct. I don't know, just understand what the problem is. How do we not have the right number of leaf nodes though? I guess in some cases it's not empty. Actually, let's do it this way. Let's see if these numbers add up. So let's actually write some code to do this. So let's find out some more information. Okay, what does this look like? Oh man, this. Okay. Yeah, static. Okay. No, the leaf nodes and the node count are wrong. Leaf count, node count is wrong. Okay. So it is how I'm building the tree. Somehow building the tree like this doesn't work properly. Okay, why? Why? What is happening? Why is this happening? Why? Does that have anything to do with how I did this? So how this is being built must be the problem. This doesn't make a lot of sense to me. I guess it must. I wonder if I change this, if anything happens. I suspect this is the problem. It'd be kind of annoying if it was. No? Something strange is going on here. It's not that. How many children do we have? Excuse me. Well, I mean, we only reached 7 of the internal nodes. There are a bunch more. Is this not actually true when they said that the root node is at 0 or at 1? Is this tree not completely connected? Is that the problem? Basically for 0 there should be the next child 3, which it is, and then the next one that has children. What does this tree look like? Are these all connected? I would be really annoyed if this was not all connected. So 3 is there. So everything that has children has to have a parent, right? 4 is connected to 3. This is wrong. This is wrong. I would be really irritated if the test case was just misleading. So you have 1 connects to a bunch of these things. Is there a 2 anywhere here? There's not. There's no 2 here. Well, what connects to 2? Does anything connect to 2? I think that's the problem. I think it's not actually rooted at... Basically, there's multiple roots, which would be extremely irritating if that's the case, because it's not the test cases. Oh, it's upsetting. Oh, it's a tree. It's a forest, not a tree. Liars. Where is 2? Who is connecting to 2? 2 on the right side. Oh, you gotta be kidding me. They lied. They lied. That's why. I'm not crazy. They just didn't do it properly. Oh, these people. How do you... There's multiple roots. Oh, my... Oh, come on, man. What kind of a... Here I am, Joe Biden. Come on, man. This is ridiculous. This is not right. Why? How do you do that? What is wrong with these people? Why? 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 That is terrible. What kind of nonsense? So actually what you've got to do, it's not rooted at the first node. It's not true at all. It has multiple, what do you call that? It has multiple trees. It's a forest. These are forests. So what you need to do, you actually need to rewrite this code such that you need to create a head node that roots all of the trees in the forest, and so your routines still operate correctly. And I guess just the value that has to be kind of a sentinel node you need to create. That is extremely annoying, extremely irritating. I'm actually just aggravated now. Actually just really annoyed. How do you not explain that in your test case? What does the discussion say? I'm pretty sure I have this, but like, please, I'm hoping that a whole bunch of people are just irritated in the discussion. What an ordeal! Own concept what a tree is, 19% about building it, 1% about the visitor pattern. Yeah, that's about right. That's hysterical. Oh no. Code version of trolling. Oh man. Along with the complexity assignment. code version of trolling. Yeah, that's probably fair. What deal? Oh, it's hysterical. Short and to the point. Is this the same person who Chef Fayette? No. Yeah, it's obnoxious. Oh, I've been doing object-oriented design and GOF design patterns for 17 years. This has no value for teaching the visitor pattern. I agree completely. Oof. Lots of ambiguous questions like these. Here's a problem solution in Java. Parsing author thoughts, inference problems. I mean, I get it, but I'm a completist. Parsing a tree from random format, then visitor pattern. 10% slightly ambiguous tree building protocol. No, but this is incorrect because the tree is not the tree's a forest. It's not a tree. Spent over an hour for this. Edges are not necessarily directed from parent to child. Yeah. That's obnoxious. Thank you. Save me time, my sanity. Rooted trees are by definition directed, and it makes this very unexpected. It means does not necessarily indicate the direction of data set or setting of rooted tree. Yeah. Just wasting my time on this. Yeah. This is obnoxious. Okay, yeah, most of the visitor part is like not the relevant part here. The most relevant part seems to be getting this correct. So, okay, let's find the parents then. Let's do it that way. So we have, we can use a hash set. That's not a bad idea. I didn't think to do that. Okay. Determine which nodes are the root of the parents or roots, trees in the forest. Problem description was horrendous, and there is a big difference between a forest and a tree. Yeah, that was really annoying. It's extremely irritating, quite frankly. Okay, so just have a hash set of integers and say nodes, new hash set, integers, nodes.add, say parents, possible, or root nodes. Remove any incident node. Yeah, that should only happen once, so that should be fine. Now, build the forest. Each tree recursively by using a helper function. Build the forest by building each tree. You return a sentinel node. Represent the root of the forest, all of the trees connecting the forest into a single tree. Build each tree recursively using the helper function. Build the forest by building each tree. Return a sentinel node that will represent the root of all of the trees. Excuse me. So yeah, basically tree node sentinel is going to be tree node new tree node of 0, 0, 0. We'll just make it red. And then we're going to say for each, in the hash set, I think we're going to say root nodes or integer root and root nodes sentinel.add child, and we're going to use build tree helper. And then we're going to return the sentinel. Okay. Hopefully this works. Wrong answer. Nice. Oh, we don't need all this output now. Get rid of all this debug code. That is really annoying though, I have to say. Alright, what does this do? Wrong answer. Your output 0. Oh, we should make. Oh no. That's annoying. So the product. That's really obnoxious. We're not gonna be able to fix this, are we? I think we need a depth of -1 for the first node, the sentinel. That might be what we're after here. What's the second one? What does it say? All red nodes. Okay. Actually, doesn't matter what the depth is, but make it a green node then. The most aggravating thing. All right, let's try this test case now. Oh man, come on. I actually don't know if we'll pass on all the test cases. It's definitely really irritating though. It's still wrong. Oh man, come on, really? Why? Why? Why is it so difficult? No, come on, man. Come on, man. What? Now, what? 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 What is going on? Oh, this is ridiculous. This is just upsetting. All right, I don't know. I don't know what to make of this. Like, what kind of nonsense are we dealing with here? This is absurd. This is absurd. Are these just the wrong sum values? Is it supposed to be a disconnected tree? Like, it's what are we doing here? This is painful. This is painful. What is going on? Let's try again. Please tell me that this is not. Why? 300? Is that real? What is going on? Bad writing. That's what this is. This is just bad. This is not tested. That's what this is. This is not just like get a couple people to try it and see what they think. This is this is what happens when you just wing it. Okay, I can see the problem though. This should be add up to 100, not 300. Why is it happening 3 times? What is going on? This is so confusing. Why is this happening? So how many? What? Okay, how many root nodes do we have? I know there's at least 2. You have 1, you have 2. Where's 3? So 1 isn't connected to 2 at any point. 2 connects to 4 though. Anything else connect to 4? No. That's what my thinking is, that there's multiple. Like, we must be revisiting the nodes. 6 root nodes. Okay, what are they? Is that true? Do we do that incorrectly? So annoyed. This is like extremely aggravating. 0, 1, 2, 5, 17, 20. So you add 1 to each of these. So yeah, 1 is a root node, 2 is a root node, 3 is also a root node. So nothing connects to 3. 6 is a root node. Nothing connects to 6. And then finally 18 and 20. 18, nothing connects to 18, and 21 rather. And nothing connects to 21. Everything else is covered though. So for some reason though, even though we have all of these root nodes, like that's fine, but how do we end up visiting 300 times? How did that happen? How did that happen? Excuse me. Oh, I think you need to, that's why. I think that's why. You need to use the, that must be it. This is so obnoxious. Is it like bugs that really shouldn't be happening kind of a thing? The way that I'm using the code to build this, the values and the colors and the children, yeah, that's why I think that's confusing. But yeah, the children, the root, this should be, yeah, it should be root, and then the other one should be the other one should be root, and the other one should be, the value should be 0 at the beginning. Is that the depth? What did I say? Where's my program here? Yeah, the depth should just be 0, I think. Vals should be vals of right. Okay, that's, yeah. That might be part of the problem. Oops. Don't do that. That's still way more than it should be. Why is it 112? Why? Ah! That's so obnoxious. It's extremely irritating. Still way over 112 and 22 for something. Like, where are these numbers coming from? Why? Oh. It's torture. This is torture. Why are you revisiting nodes? How is that even happening? This is torment. Do any nodes have more than one? Like, there's no way. That would be so annoying. There's a B that shows up more than once. I would be furious. There's a very high chance that there is. And I would be so annoyed. Check dupes. I will be furious if that's the case. Please tell me that's not the case. I think you add I. How could this be? How could this be? How could you? Alright, so we don't have any duplicates. That's good. I'm losing my mind. Oh, we've been at this for almost 2 hours now. Okay, that's what we expect. 100. Roughly 100. Okay, that's good. I have 6 root nodes, so we don't have... so that's good. But where is my code wrong somewhere now? How does that even... how did that happen? Have all the root nodes. How are we visiting nodes too many times now? That's my question. Because we have this sentinel as a tree node, it's going to have children for each of the root nodes, which you build the tree helper with each of those nodes. How do we end up with more nodes? I'm really confused. Do this again. This is really annoying, I have to say. This is like, how... is there some other thing that he did that's really unexpected? That just doesn't make sense. Is that what's happening here? Or did I genuinely make some mistake somewhere? I really... this is actually just infuriating. The word is completionist. That's the kind of person that puts up with something like this and keeps going. That's the word you'd be looking for here. Okay. Ooh. Leaf count, node count. Wrong. That is the wrong number. How is that possible? How is that even possible? Why? Why? We have way too many nodes. We end up with... we end up with 100 and... we end up with 12... we end up with 34 extra nodes. There should only be 100. Oh, this is so annoying. 34 extra nodes and you should only have 100. Why is that? Why does that happen? How is that even possible? Oh, this is upsetting. It's gotta have something to do with how the children are built. is there a loop somewhere? I mean, it can't be a loop. It's got to be. What? How could? How? How is it even possible? How is that even possible? Literally how? Please tell me. You could do this here. Do it this way. So for each root node, we're going to build a tree, and then we're also going to take all of those root nodes and make them children of the sentinel and return sentinel. Okay, that's fine, but then as leaf count, what happens as we go? Oh, what happened to my test case here? Yeah, I would say this is like just absolutely infuriating. I think I'm gonna just go to bed after this. Oh. Gonna remove this altogether. Okay, so the first one we have, okay, that's what we had the first time, 44 and 7, and then 79, 13, 103, 18, shoots way over. What's interesting is the last two. Huh. That is just bizarre. What is going on? I'm gonna do this as I'm losing my mind. Actually, just losing my mind. How is this possible? Let's count all the children. No, well, no, this. What is going on? Doesn't make any sense. Why? It's funny too, just earlier I was thinking about, there was a video I was watching with a programmer where he was talking to his daughter, and his daughter was like, I could hear you cursing under your breath while you're learning to program. And I was like, why would a programmer ever get that angry with software? And here we are, just yelling, just extremely irritated and frustrated and wondering why this isn't working. Dude, I have no idea. I couldn't even begin to tell you. This doesn't make any sense. It's flat out. There's something I don't understand about how this was put together by the guy that wrote it. It's gotta be it. There's gotta be something that he did that was just really unusual and it's causing a problem. So how is this? Yeah, how is this even possible to have? There's only 100 of these. Or 99 of these. We found the ones that don't have any incident edges. Okay. Wait a second. If they don't have incident edges for some of the nodes, in other words, they don't have a parent, that means that one of these nodes has to have more than... Dude, this is so confusing. This is so confusing. come on, man. That is so obnoxious. That's what's wrong. Also, my check for duplicates didn't work for some reason. And I think okay, here's the issue. Yeah, this is ridiculously obnoxious. Dude, you gotta be kidding me. Basically, some of these edges are from A to B, and some of them are from B to A. So effectively, these edges are undirected. That's pretty much. I think some of the people mentioned that in the comments that the edges are undirected. So it is rooted at 1, but you need to. Dude, this is like the most painful way to express this. So it's not a forest. That's actually not the case. What's weird about that, because if there are 6 nodes that don't have parents, you can use, I guess it's pigeonhole principle, I suppose, or something. I'm not even sure what the principle is, but if there's 6 edges that don't have parents, but you have 100 edges, and the idea is that every node, or you have 100 minus 1 edges, because every node has an incident edge on it, right? That means the ones that don't have an incident edge on it, there needs to be some other edge somewhere in the graph, 6 of them, which actually means that you have basically crossing over of some kind. Now, what's really weird about that is I was expecting, I really should have uninstalled that. It's extremely irritating seeing that all the time. What I'm wondering or guessing is that if you, so some of these nodes don't have incident edges, but I think I should have had duplicates. I don't know why I didn't see that when I ran my code before with the duplicates. You should have actually had duplicates. So that's kind of annoying. I actually should have seen duplicates. I think that's the problem. Well, no. It's not. That's really confusing too. It's not duplicates from A to B. It's that these values that don't show up on the right side anywhere, they actually connect back, to something else. So A to B, and then that B goes back to something else. So these are actually each subtrees, and they seem disjoint, but there's actually some. So okay, so let's take an example. So we had the supposed root nodes. I see the problem. Oh, dude, this is so obnoxious. It's like the most obnoxious thing ever. Comment these out. Yeah, this is really irritating. I think what he did was he used undirected edges, and then he just sorted all the edges increasing from left to right. And that's why it's really obnoxious. Yeah, 2 integers, and there's just an edge between 1 and 2, and then he probably just sorted the 2 values, which is just such a confusing way to do things. So, yeah, okay. So 0, so 1, 2, 3, 6, 18, and 21. Let's go to 21, right? So 21 is at 98. I think, yeah, 98 connects back to 6. So actually my check for duplicates should have worked. But my code when I wrote that didn't work either. That's so annoying too. That should have worked. What happened to my check dupes? Contains. B. So this code, for whatever reason, that should have actually printed duplicate. Yeah, there you go. 1, 2, 3, 4, 5. I don't know why that didn't work before. What happened? I think I wrote it incorrectly or something. I don't know what I did. Yeah, there's okay. Oh, it's obnoxious. Okay. Right. So this is just absolutely ridiculous. So you don't need a sentinel. We can go back to what we had before. Dude. This is painful. This is just painful. Why would you do this? Can you just clarify that next time? Horrendous. Not clearly stated. The format, the input, it's not clearly stated. Problem. Yeah, I'm not gonna say anything. I'm just gonna. It's fine. Yeah, that's just horrific. So okay, that's. Okay. We don't need this root nodes anymore. Or dupes. How do you? Yeah, you would assume. One would assume the edges would be undirected, but these are, or would be directed, but they're using undirected edges for some reason. Just really just throws everybody off. That's what everyone's complaining about in the discussion. Alright, so basically, how do we do this? How do you even parse this now? What do you even do? I don't know. Which one's the child? Is it A to B or B to A? You have to figure that out. Figure it out. I think you can maintain a hash set of the things you've already seen, and if you've already seen that, then that means that the one you haven't seen yet is the child. The one you've seen is the parent, and the one you haven't seen is the child. Yeah, that's extremely confusing, but that's how we're going to do it. So scene nodes. This is like so unnecessary. Okay, so the first thing we do is scene nodes.add. We're going to add 0. Say if scene nodes contains A, then that means that A is the parent and B is the child. Otherwise, it's the other way around. And then we're going to say scene, and we're going to add these, right? We're going to add the child, B, and in this case, A. Okay, we could try this, see how this works. I'm just irritated now after all of this. 6913. Dude, this is torture. Oh, why? Ah, why? Come on, man. Come on, man. This is actually just torture. Also, where are these numbers being printed? 6913. Oh, this is the most obnoxious thing ever. No. Ah. Why? How would you do this? What's wrong with you? Ah. Why is this so hard? Oh, my brain, dude, it's freaking it's gonna pop. This is ridiculous. This is so ridiculous. I have to write like a whole graph class and then just, oh, come on, man. Okay, so, okay, we can do it this way. We can say, undirected. Who does that? Who makes undirected graph? Why? All right. So we're gonna use a graphing algorithm to do this. We're gonna do it. There's a special way to do this. This is so obnoxious. Okay, what you're actually gonna do is the following. Ready for this? So it's actually gonna be the neighbors, not the children now. I thought we could finagle this with this hash set, but whatever, it doesn't work. Okay. It's not children anymore, it's neighbors. You can only have a neighbor set now, because now it's a graph and not a tree. Come on, man. This is so annoying. Who does this? Why would you do this? Why? It's horrible. Horrible. So now everybody is neighbors. Everyone's a neighbor. And now what you need to do is keep track of your parent when you build the tree. Ah, this is so annoying. Yeah, let's do that now. And now when you run your routine, you're going through the neighbor set, not children anymore, neighbors. Because it's a graph, not a tree. No. I'm really irritated. It's like, I can't believe it. Why would you? So if no longer children, neighbor. Neighbor. It's not empty anymore, it's the size. Only the parent. I appreciate all the people who are like, this is a waste of time. It's such a waste of time. This is great. Oh man. Yeah, so it's the neighbor, and which node is the to say tree, next node, subtree. Okay. I guess we could just do it like this. It's kind of better if we put this on the over here. It just has all these parameters now. It's kind of obnoxious. It's a little bit obnoxious. Okay. Yeah, the parent becomes this which node. Alright, does this compile at least? Hopefully, presumably, no. Neighbors. Now we got neighbor sets. Okay. There we go. I don't want to cry anymore. Still want to cry, but I don't want to cry as much. Dude, that was brutal. Oh man. Wow, really? Oh, okay. I just need to get rid of the debug code now. That was actually just horrific. It's pretty much just a nightmare. Yeah. Does it work? Let's find out. Let's see if we fail any other test cases. Oh! Oh! Really? Of course. Why do we fail some test cases, not others? Why would you do this to me? Why? This is painful. There's yet even something else. There's even something else that's wrong. Of course. The Stack Overflow. Of course. Of course. Of course. How did that happen? How is that even possible? Why? Do you need to have an already seen set? So when you're traversing a depth first search, so basically what happened is it's supposed to be a tree though. What? What do you mean? Dude, this is so bad. This is so bad. This is like horrifyingly bad. Okay. If it's a tree, then there shouldn't be any cycles. There should be no cycles. The only possible cycles you could have for the neighbors would be the parent they just came from. Which we said our neighbor set's gonna have the parent in there. As long as the neighbor's not the parent, then we can check our neighbor, and parent becomes this which node. How is there a cycle? Why? What? Why? Where is the cycle happening? Dude, this is painful. painful. This is painful. Yeah, we just print. It shouldn't be happening. This should be sufficient, but for whatever reason it's not. Of course not. There is a way to avoid this, but no. We're not going to count anymore. I think we got it. Figured out what's wrong. So annoyed. Should be. It's gigantic. Well, okay. Yeah, it's just looping over and over again, right? At some point. Yep. Okay, why is there a cycle? 0, 3, 136, 150, back to 136, back to 3, back to 0. How did that happen? 0 to 3, then 3 to 136, then 150. And how does 150 go back to 136? This should be its parent. It shouldn't. 136 should be the parent for 150. It should be able to go back to 136. What is going on, man? Why is this so painfully difficult? Yeah, it's like every problem I run into, I'm annoyed that the person didn't set up the code to be directed. So I'm just like, this shouldn't be happening. So I'm just, every problem that comes up, I'm irritated by. Alright, but this doesn't make sense, right? You update the parent to which node, and then, how is this happening, I guess is my question. $150, and then there should be 136 should be what's the, yeah, okay, let's try that. Zero, negative 1, 3, 0, 136, 3, 150. How is this happening? This line of code is supposed to prevent this from happening. How do you, the parent is 136. How do you do 136, 150? How is that even possible? That's not possible. That's not possible. Oh, are these objects? Is that why? It's because I'm using integer objects. I think that's why. Oh, Java. Oh, Java. Yeah, I think that's why. It's because it's integer objects. If they're objects that are wrapping, you need to use an equals, not a... Maybe? I don't know. Let's find out. That's a really subtle thing. I would have noticed that. Yep, that was why. That is so annoying. Alright, see if there's anything else we missed. Oh, no, nothing's working. Okay. Oh, that's because we have printout code. I completely forgot. setting. It's good to run your code first before you submit it. I don't know how many times I submitted this now. Oh, finally right. There we go. Did it. We finally did it. Oh, that was a horror. Oh, dude, that was so painful. That was so painful. Oh. I guess I'm glad we went through that. I mean, really, though, we didn't need to go through all that. That was really just painful. Dude, why would you do that? What's wrong with you? You torture your oh man, how much time we spent on that? We spent hours on that, dude. We spent like 3 hours on that. I don't know what to say other than like that was awful. I think that really was just like a lot of it really just wasn't clear enough, I think. Like, you really gotta say these are undirected, these edges. Like, you could have inferred that. Like, technically that's what he said, but you know, and then handling undirected edges in a graph is like very different from handling directed edges. As you saw, it's a lot easier to just create a neighbor set of the undirected edges and then just don't go back on the parent, and that'll work if it's a DAG. It's kind of obnoxious, but it works. With undirected edges, it's a lot easier. I'm so annoyed. I'm so annoyed. Just technically you said this, but like that's not really clear enough. I mean, you really gotta. Yeah, I don't know, man. This is actually really part one, by the way. This is the first thing you have to do, and then this part you can do after. I don't even like this problem either in terms of like the implementation. Like, I wouldn't want to use these visitor classes because they're not, as I said, the operations are not idempotent when you run each function. When you run each function, the problem that you're going to run into is when you run each function, the problem you're going to run into is if you visit, or if you run the accept more than once with this same visitor, then so if you accept the visitor more than once, this current result will get overloaded. You know, get too much. It'll basically, yeah, potentially overflow, or it's not idempotent, the accept for this class, and I don't think there's a way to enforce that either. I think you'd need to like have some kind of bit for the visitor to like make it idempotent, that when you run the accept routine, it automatically, maybe it's part of the tree viz, would make it idempotent, or maybe you'd have something as some variable as part of this tree viz that when you call accept, or if you overload accept, maybe something like that. I don't know. Well, the accept is actually part of the data structure, not part of the visitor. So if we look at the implementation, yeah, the accept is actually part of the tree. So I don't really know. I don't know how you could do that to make the visitations like idempotent. I really don't know how to do that. I guess you can't. I don't know. But it's an interesting way of doing this. I kind of don't agree with this overall. I don't really like the pattern. As I said, I don't really like that having that much separation between the iteration and like what you do on each iteration. One, it seems kind of unnecessary, and two, like it's not really that, like you're not really gaining that much. And then the other part is you're also running you have the problem of like I said, like, you know, with this class, it's not idempotent from the perspective of the class, whereas other ways of doing this, like if you just had a collection and you ran a lambda function, sort of the variable at the end, it's sort of like, I guess you have more control. I don't know how to express it exactly. It's like you don't necessarily, you can sort of make like one-off iterations on your data structures rather than having a class that performs that iteration, because the context that you're writing it in, it's clear what you're trying to do, and so you won't have that notion of like, you know, running this routine multiple times and it's not idempotent. Yeah, I don't know. I mean, you could just have a data structure that exposes the ability to iterate over it, and you can give some function to do that. That's perfectly fine. You know, that does basically the same thing as this. Although I guess you have a little more control with this kind of thing, where you can say like you can say, okay, we want to only iterate over the leaf nodes and only iterate over the internal nodes, which is a bit different. But you could add functionality to your a data structure such that you can say like, okay, we're gonna have categories of certain elements in the nodes, and then we're only going to operate, you know, this iteration is only going to iterate over that part, something like that. I don't know. I'm not really sure. I'm not like sold on this pattern here. I'm kind of like conflicted about it, but wow, glad that's over with. That was brutal, man. It's like half the time the challenge is just trying to figure out what they're asking. Annotation can be used, or not half the time, but a good amount of the time. So I think I'm just going to go to bed, though. I think that's enough. So we have another 24 problems to go through. That's fine. We'll pick it up tomorrow. But yeah, thank you for watching. I will talk to you soon. That was rough. That was definitely rough. I was expecting a DAG. I was expecting directed inputs, and it turns out they were undirected, and I needed to use a graph traversal instead of a tree traversal, but it was still a DAG, just an undirected DAG. So, by the way, what's interesting about undirected DAGs is that you actually can make any node can be the root in that instance. So, yeah. Right. Obviously, the way to perform that operation that you saw is you just don't recurse back on the parent, and you just always kind of move out that way. All right. I'm gonna go. Thank you again for watching. I will talk to you soon. Have a good rest of your night, and yeah, tomorrow we'll pick up where we left off. We'll just keep working on these problems. So yeah, take care.